Alright, welcome to the Algebra 2 quad test review. So on number 1, we're just going to graph the quadratic function that's given. So they gave us y equals x minus 1 squared minus 4. So based off the function, we know the transformations are going to be right 1 and down 4. The vertex would also be at 1, 4. Also, if you know the vertex, you know the axis of symmetry, that would be x equals 1. So at a vertical line at 1, that's when the parabola would get cut in half. Alright, so for the vertex, let's put that in the middle of the graph, or middle of the table. So 1, 4, and then let's put it on the graph, 1, 4. Alright, so let's get the points. We go to y equals, type in the function, go to your vertex. So we have 1, or sorry, this should be negative 4. Alright, so we have 1, negative 4, and then for 0, negative 1, 2, and 3, we have 0, negative 3, negative 3, 0. Alright, so let's put those points on the graph. We have negative 1, 0. We have 0, negative 3. Again, this vertex was wrong, so let me put that correct. On the correct spot, it should be 1, negative 4. Then we got 2, negative 3, and 3, 0. Alright, so that would be your parabola. It has a domain of negative infinity to infinity. For the range, so bottom up, look at the y-axis. We start at negative 4 and then continue going up to infinity. Alright, the graph also opens upward. Alright, then for your x-intercepts, we touch the graph at 3, 0. And we touch the graph at negative 1, 0. Now for the y-intercepts, we touch the y-axis at negative 3, 0. Oh, sorry, 0, negative 3. Alright, so that's number 1. Then for number 2, let's do the same thing. Graph the quadratic parent function on the same graph. Alright, so this time that we want to see the difference between the new function and the parent. Alright, so this would be the quadratic parent function. Alright, so this would be the parent function. Alright, so let's look back at this one. This one would have a reflection over the x and a vertical expansion by 3. Right, so we don't have an h and a k, so the vertex would be at 0, 0. That means the graph gets cut in half at x equals 0. So right there. Domain would be, oh yeah, sorry, we still got to graph the new one. And so y equals negative 3 x squared, go to the table. Alright, so there we go. Alright, so at negative 2 we have negative 12. At negative 1 we have negative 3. Alright, so we got 0, 0, negative 1, negative 3, 1, negative 3, and then -2, -12, that's going to come off the graph. Same with 2, -12, that comes off the graph. So this is going to be a really narrow parabola. Right, so we have a parabola that's a little bit more narrow compared to the parent function, and it's going to be upside down. Right, the domain would still be -infinity to infinity. Now for the range, since the graph is going to be upside down, this would start off at -infinity, and then as you move your way up, you stop at 0. And the graph opens down. Alright, for your y-intercepts, we are going to have none. Or sorry, we do have one. It'll be at the vertex 0, 0. And then same for the x-intercept. It will also be 0, 0. Alright, so the only time we touch the y-axis is at 0, 0, and the only time we touch the x is at 0, 0. Alright, so next page, let's start off with the transformations. We got a vertical compression by 1/8, and we are going to go left 3. Since the graph is going to move left 3, that means your vertex is going to be at -3, 0. Alright, so put that on the table, and now let's get the rest of the points. Alright, so locate your vertex, -3, 0. And then we have points at Alright, so at -5 we have a point at 0.5, which is a half. And then at -4 we have a point at 0.125. And same on the other side. Alright guys, so now we have the points, so let's put them on the graph. So we have -2, 0.125, so just barely go up, and then -1, just go halfway up. And same thing on the other side. Also, this is a vertical compression, so we know that the graph is going to be a lot wider. Right, for the axis of symmetry, again, since you know your vertex, it's just the x value, so x equals -3, that's when it gets cut in half. Domain would be -infinity to infinity, and then your range would be from bracket 0 to infinity, and it opens up. Alright, so now for the focus and the directrix. So if we want the focus and directrix, we got to know the p value. So to find p, it's a equals 1/4p. Since our current a value is 1/8, the one number that would give you an 8 on the bottom would have to be 2. Alright, so the p value would have to be 2. Alright, so the focus should be inside the parabola. So if I go 2 units inside, we end up at -4. Sorry, 1, 2, 3, -3, +2. So -3, 2. That's where the focus would be. Now for the directrix, go the opposite direction but the same distance, 1, 2, and that would be where your directrix is at. Alright, so here it happens to be at y equals -2. Alright, so it's a horizontal line at -2. So it should start off with y equals. Alright, so now on the graph, our x-intercept was at the vertex, which is -3, 0. And then your y-intercept is wherever x is 0. So let's go on the table. When it's 0, it's 1.125. So then for number 4, 5, and 6, write a quadratic function that shows the given transformations. Alright, so the given transformations, we're going right 3, a vertical expansion times 4. So this would be y equals 4 in the front, parentheses x minus 3 squared. Alright, so we're going right 3, expansion by 4, vertical expansion by 4. Now for number 5, we're going to go up 7, but reflect over the x-axis. We need a negative in the front. Nothing goes inside of parentheses, so we could just put x squared, and then at the outside put plus 7 to move up 7. Alright, so now on 6, we have a vertical compression by 1/5. So that's the a value. Then we're going to go down 3, left 1. So if I want to go left 1, we need an x plus 1 on the inside. And then if I want to move down 3, put minus 3 at the end. And then don't forget to put your squared, because that's what makes it quadratic. Alright, now for number 7, 8, and 9, we are going to complete the square. Alright, so just a heads up, different teachers complete the square different ways. So on number 7, I'm going to use my method first. Alright, so step 1 is to set it equal to 0. Alright, so I'm using my method again, so set it equal to 0, then move the 6 to the other side. Alright, so now to find the new c value, take the b value divided by 2, then square it. So right now the b value is negative 12. So if I take negative 12 and divide it by 2, we get negative 6. And then square it, you get 36. So we get plus 36 on both sides. And then factor the left side. So two numbers that multiply to 36 and add up to negative 12. Here, so let's do that here. 36 and negative 12, that would have to be negative 6 and negative 6. Alright, so our factor is x minus 6 squared equals 30. Alright, now move the 30 back to the other side. Alright, and then this is supposed to be an equation, so make sure you put y equals in the front, then put the function x minus 6 squared minus 30. Alright, so now let's look at number 8. So another method you could complete the square with is doing it this way. So y equals x squared plus 16x. Then leave some space, then just put the minus 7 there. Find your new c value. So 16 divided by 2 squared. That would be 8 squared, which is 64. Right, then this part's a perfect square trinomial, so you could factor it. You get x plus 8 squared, then negative 7 minus 64, that would be minus, let's see, that would be minus 71. Alright, so your vertex would be negative 8 comma negative 71. Alright, so then for number 9, I'm going to use my method. So my method, I set it equal to 0. Move to 16. Alright, then find your new c value. So take negative 6 divided by 2, then square it. Alright, so then add that 9 to both sides. Alright, so then factor this, you get x minus 3 squared, and this side, 16 plus 9, that would be 25, and then move the 29 or 25 back, or move it to the left side, so subtract 25. And then this is the function, but if you want to make it an equation, you have to put a y in front of it. So again, there's different ways of completing the square. 7 and 9, I used my method, and then 8 might be a different method that you were taught. Alright, so let's go to the last page. Alright, so number 10, an object is fired straight up from the So an object is fired straight up from the top of a 200-foot tower at a velocity of 80 feet per second. The height h of t of the object t seconds after firing is given by h of t equals negative 16t squared plus 80t plus 200. So what are the domain and range of the function? Alright, so when it says of the function, we're looking at the whole parabola, like if you were to graph it on the calculator. If you were to graph this on the calculator, you would get a full parabola going downwards. That would have a domain of negative infinity to infinity, and then since it opens down, your range would be from negative infinity, and then we stop at 300. Alright, so negative infinity to 300. Alright, so now let's look at B. So this one's a special one. So this one's special because it's saying what is the reasonable domain and range of the situation. So if you see reasonable in situation, think about this in real life. Alright, so let's look at the domain, which represents the x values. Alright, so we're talking about time. So in real life, you wouldn't consider the negative seconds. You would just care about the actual seconds, or the positive ones. So there's no negative time, there's just positive time. So we start at 0 seconds. So that's right when you throw the object, and then it takes 6.83 seconds for it to come down. So the domain would be from 0 seconds to 6.83. Alright, so that's the domain for this particular situation. Now for the range, so now we're looking at the height. So the smallest height that you could have is 0, because that's when it hits the ground. The maximum height was at 300. So your range would be from 0 feet to 300 feet. Right, now for C, find the maximum height recorded by the object and the time that the height was recorded. So the maximum height is right here. It's at 300 feet. And then if I go on the x-axis, we see that it's right in between 2 and 3 seconds. So that's going to be at 2.5 seconds when it reaches 300 feet. Alright, so it's going to take 2.5 seconds to reach the max height of 300 feet. So it's at the vertex or the maximum point at 3.5, 300. Or 2.5, 300. That would be the vertex, also known as the maximum height in this particular situation. Right, then for number 11, the height of a fountain's water stream can be modeled by the quadratic function. What is the maximum height of the fountain's water stream? So the maximum height would be right here at 1/8. So the height would be at 8 feet. Right, now on B, circle or highlight the part of the graph that shows where the water stream is at least 6 feet in the air. So we're at least 6 feet in the air between 1 to 2 seconds. So this boundary right here. Alright, so that's when the water stream is at least 6 feet in the air. So just in that little region right there. So just circle or highlight it. Alright, now for number 12, we're just going to do regression. We're going to do regression. Alright, so go to Stat, Edit. For L1, type in your X value, so 0, 1, 2, 3, 4, 5, 6, and then for L2, type in your Y values. Alright, so once you have your L1 and L2s inserted into the calculator, go to Stat, Calc, Quad Reg, so 5, enter. Alright, so then we get our points, or we get the data. So let me just make sure I inserted this correctly. So 28.82, 28.5, 26.8, 23.9, 18.5, yeah. Alright, so this equation would be y equals, so round to the hundreds, negative 0.87x squared plus 1.15x plus 28.16. So let me just rewrite that. Alright, so that would be the regression equation. So you get that from A, B, and C. Alright, now for 13, 14, and 15, you're just trying to see which one is a quadratic, which one represents quadratic data, so just do second differences. So if I look at 16 and 8, it's going to take me minus 8 to get there, 8 to 0, minus 8, 0 to minus 8, minus 8, negative 8 to negative 16, minus 8. So this one, the first difference is all the same, so this would be linear. So this would not be considered quadratic. Alright, now for 14, do the same thing. 1 to 3, you have to add 2. 3 to 9, plus 6. 9 to 27, plus 18. 27 to 81, plus, I think that's 54. Let me just make sure. Yeah, 54. Alright, so now let's check out the second difference. 2 to 6, you plus 4. 6 to 18, you plus 12. 18 to 54, you plus 36. Let's see. Plus 36. Alright, so that's the second and first difference. They clearly do not have the same value, so this is not going to be quadratic. Then on 15, 4 to negative 5, you minus 9. Negative 5 to negative 8, you minus 3. Negative 8 back to negative 5, you have to plus 3. Negative 5 to 4, you plus 9. So that's the first difference. Now for the second difference, do the same thing. Negative 9 to negative 3, you plus 6. Negative 3 to plus 3, you plus 6. 3 to 9, plus 6. So on the second difference, those are all the same. So this one is going to be the quadratic data. Alright, and that's the end of the quadratic review.